Guys, in this video we are going to talk about how two mass can be weightless and how we can derive Newton's law of universal gravitation between two masses. So basically every two masses attract each other. The force of attraction between these two masses is directly proportional to the product of the two masses. The first point that you should put is the force between these two masses. Actually, a pair of forces are exerted by these two masses. Mass 1 is pulling mass 2 and mass 2 is also pulling mass 1, because force exists in pair. There is no a single force in nature. One attracts the other. So according to this law, the force either of the force F1 on 2 or F2 on 1 is directly proportional to the product of the two masses. So mass 1 times mass 2. And the same force is also proportional to the square of, inversely proportional to the square of the separation, the center to center distance r. So meaning as the center to center distance is larger, the force exchanged by the two masses decreases, and vice versa. And here, as the product of the two masses is larger, the force exchanged by the two masses is larger too, and vice versa again. Now the logic we can put here is the force of attraction between two masses, which is always attraction, is directly proportional to the product of these two things, mass 1 times mass 2 and 1 over r squared. So this proportionality is turned to equality by multiplying these things by some constants. So the constants are determined experimentally. So the force of attraction between two masses is equal to mass 1 times mass 2 times 1 over r squared times some constant. The name of the constant is G. G is called Newton's gravitational constant, universal gravitational constant. So the force of attraction between two masses, Fg, is equal to G, universal gravitational constant, times mass 1 times mass 2 over r squared. Okay, so the force is in Newton, the radius is in meter, and the masses are in kilogram. So what will be the unit for the G? Solving for G, we can have a force of gravitation. The force of gravitation multiplied by r squared is equal to universal gravitational constant times mass 1 times mass 2. So the force of gravitation times r squared divided by the masses is going to be your G. Okay, so this formula, so this is the expression for universal gravitational constant G. So this case, F is in Newton and r square is in meter square because radius is in meter, and divided by mass 1 is in kilogram times the other mass is also in kilogram. So this will give you Newton meter square over kilogram square. This is the unit for universal gravitational constant, meaning SI unit for G, universal gravitational constant, is Newton meter square over kilogram square. The value of G is, this G, the constant, is equal to 6.67 times 10 to the power of minus 11 Newton times meter square over kilogram square. Or you can write this is equal to 6.67 times 10 to the power of minus 11 meter per kilogram totally square. So this is the gravitational constant, and according to Newton's second law, two masses are exchanging the force F gravitation, which is equal to the universal gravitational constant times mass 1 times mass 2 divided by the square of the center to center distance, r square. Okay, now how do we define weight? So weight of something, from the above discussion, we have already concluded gravitational force Fg, which is equal to the gravitational constant times mass 1 times mass 2 divided by r square. Now, what is weight? When we talk about weight of something, it is the gravitation weight of this guy, for example. It is the gravitational force of attraction between the earth and the guy. Okay, the earth is pulling the guy and the guy is pulling the earth, so they exchange force. So how do we define weight of this guy? So the weight of this guy is the gravitational force between these two guys is given by g times mass of the person, the guy, times mass of the earth divided by the distance square, the center to the center distance square. Now the weight of the guy is equal to, I can write g times mass of the earth over radius of the earth. Compared to the earth's radius, the distance of the guy from here to here is very small, so just we can take the radius of the earth times the mass of the guy. Okay, now but this mass of gravitational constant times gravitational constant g times mass of the earth divided by radius of the earth square is gonna give you the acceleration due to gravity. So we simply put the weight of someone, which is a gravitational force between that person to the earth, is given by g times its mass, but it's because this g is the same as the gravitational constant times mass of the earth over radius of the earth square. So if you calculate this one, taking g as 6.67, mass of the earth is 6.7. So taking mass of the earth 5.67 for 2 times 10 to the power of 24 kilogram. Radius of the earth is 6.371 times 10 to the power of 6 meter, and gravitational constant is equal to 6.67 times 10 to the power of minus 11. We can calculate the value of this g. So the acceleration due to gravity g is universal gravitational constant times mass of the earth times radius of the earth square. Substituting the values, g is equal to 6.67 times 10 to the power of minus 11 times 5.9742 times 10 to the power of 24 actually kilogram, divided by radius square of the earth is 6.371 times 10 to the power of 6 square. So calculating this, g is equal to 6.67 times 5.9742 divided by 6.371 square. So that means 40.58941 times 10 to the power of minus 11 plus 24 minus 12. That gonna give you 0.9817 times 10. This gonna give you 9.81 meter per second square. Now that's why this gravitational constant g is equal to g times gravitational constant g times mass of the earth divided by radius of the earth square is equal to 9.8. Now let's talk about the weight. All right, weight of somebody is g times mass of the earth divided by radius of the earth square times mass of the person, and g is equal to acceleration due to gravity. G is equal to gravitational constant g times mass of the earth over radius of the earth square. Now the weight of somebody is 0 when the mass times gravity is 0, but the mass could not be 0. What could be 0? So the g could be 0. Where do g be 0? So we have to put the formula. So g can be 0 when gravitational constant mass of the earth over r square is 0. Now r is radius of the earth. If he is on the surface of the earth here, then r is the radius of the earth. When he moves somewhere very far, r is gonna be what? R is gonna be just simply r. Now where do this become 0? Now g cannot be 0. It's a constant. Mass of the earth cannot be 0. It's also constant. So where can be this g 0? 1 over r square goes to 0. So 1 over r square is 0 when 1 over r square goes to 0 when the distance between the person and the center of the earth is very far, meaning 1 over r goes to 0 as r goes to very large number. So when the earth is here, the person is very far from the earth here, so this force of exchange between the person and the earth is 0. When r is when r goes to, the radius goes to 0, meaning when the person is infinitely far from the center of the earth. So someone feels truly weightless, truly weightless, okay, when he goes very far, when the distance between the earth's center and the person is very far, okay, very far, infinitely long. So thank you.